Hello there, everyone, and welcome to the Broken Vertebrate Paleo channel. I'm very proud to announce that this is the first video in this channel. I'll be your host today, Soap the Smilodon, to take you all the way from the past up until modern day times. So, by clicking on this video, you tell me you have an interest in fossils. You might be curious, how are fossils formed and what kind of fossils are there? Lucky for you, I'll explain all of it for you. So by the end of this video, you'll be able to understand how are fossils formed and what kind of fossils are there. So let's talk fossils. Because apparently dead things don't just disappear. Sometimes they get promoted to museum status. I'm talking about the process called fossilization. Nature's way of saying, you died, now let's make you an awesome rock case. A fossil isn't just any old bone. It's the preserved remains or evidence of ancient life. Think of things like shells, bones, footprints, and even poop. Yeah, poop. Scientists call that coprolite, by the way. You can thank ancient creatures for literally leaving their crap in history. So, how do these fossils actually form? Let's break it down, like a natural history course. First, you start off with a living creature, like I've drawn in this corner here. We'll call him Jim. Unfortunately, one day, let's say Jim caught a disease, and he passes away. Unfortunately, now that Jim is dead, he'll start his process of fossilization. Now, getting fossilized is actually quite rare. It has to be in the perfect conditions and environment. Every fossil story begins the same way. Someone dies. Sorry, no happy ending. But step 2. The burial of the body. Now that Jim has been lucky enough to get buried, the body has to get buried fast. If sediments like mud or sand covers the remains quickly, it protects from scavengers and decay. As Jim's body has been underground for a while now, and water starts to seep in, it becomes a process called mineralization. Over time, water will carry minerals and it will seep into the bones or shells of the organic material. As this starts to happen, the organic material will break down and minerals take its place, turning it into stone. It's called permineralization. So in other words, it's nature's fancy way of replacing squishy stuff with rock stuff until boom, you get a fossil. But fossils aren't just bones. Oh no. The fossil world has many different kinds of fossils, and I'm about to teach you all about them. We'll start with the easiest one, and most famous kind, body fossils. Like my dinosaur friend here, Jim, as you can see in the left corner, these are the main characters. Bones, teeth, shells, tusks. You know, the celebrities of fossils. These form mostly through that mineralization process we just talked about. And in even cooler cases, there's a kind of fossil called mold and cast fossils. Like I shown in that little seashell I drew up above. Sometimes the organism dissolves but leaves an impression in the rock. That's a mold fossil. If minerals later fill that mold, it becomes a cast fossil. Basically, nature's way of 3D printing something that's been long gone. And the next kinds are even cooler. They're called trace fossils. They're one of my most favorite kind of fossils that form. These fossils usually contain footprints, or even in rare cases, dinosaur butt prints. Kind of comedic, isn't it? These record activity, not body parts. Things like footprints, burrows, and yes, poop again. Trace fossils tell us what animals were doing instead of what they looked like, which can help a lot when understanding the prehistoric world and how these animals lived and behaved. Now, one of the most famous kind of fossils, as we all know from a certain kind of movie, hint hint, starts with Jurassic, but they're called amber fossils. You know that scene from Jurassic Park with the mosquito in the amber? Totally real science. Resin from trees can trap insects and harden into amber, preserving them in wild details, from bugs to even dinosaur feathers coming from their tails. And last but not least, carbon fossils. This is only when a thin layer of carbon remains from an organism, often on plates or soft body creatures. It's basically a shadow fossil, nature's version of tracing paper. So, overall, these different fossil types formed depending on conditions and what the organism was, how fast it was buried, and what the environment was like, and how long it sat there. No two fossils are ever the same, but every one of them tells a story about ancient ecosystems, climate, and evolution. And that's the beautiful thing in life, that fossils aren't just rocks. They're ancient clues. They're time machines that scientists read like chapters in Earth's history. Every single little fossil tells a very important story. So next time you pick up a rock, just remember you might be holding the remains of a 66-million-year-old tyrant lizard king. Or maybe turtle poop, whatever your fortune is. Either way, it's pretty cool. Science isn't just about memorizing things. It's about imagination, how the world used to be. Fossils are our postcards from deep time. And along with being postcards from deep time, they also had dreams just like me and you. They had families, they saw the world, whether from ancient hominins all the way to dinosaurs. They should be well respected and seen as living sentient beings that are no longer with us from a long distant past. And with that, I hope you enjoyed the first video on this YouTube channel and subscribe and like to see more. I'm always free to suggestions in the comments or corrections. I hope you have a wonderful day and don't get fossilized.